So far, when we've been talking about linear equations, we've been talking about linear equations in slope-intercept form. However, there are other types of forms that we can see linear equations take on. For example, the first one that we're going to look at now is standard form. So an equation of the form ax plus by equals c, where a, b, and c are all real numbers, is said to be a linear equation in standard form. A real number is just a number that can be found on a number line. There are advantages to either form of a linear equation. In standard form, it is typically easier to figure out the x and y intercepts. In slope-intercept form, it is typically easier to find the slope and the y-intercept. So, example 4 says find the x and y intercepts of the linear equation 5x plus 3y equals 10. Then change the equation into slope-intercept form. If I created an input-output table, so here's x, here's y, the y-intercept is the ordered pair where the x-coordinate is 0, and the x-intercept is the ordered pair where the y value is 0. So let's go ahead and plug in 0 for x and solve for y and see what we get. So I'm just plugging in 0 into our equation, and 5 times 0 is 0, so we get 3y equals 10. And if I divide both sides by 3, then I get y is equal to 10 thirds, which is 3.333 repeating. Now I want to solve for the x-intercept. So I am going to set y equal to 0. And so I get 5x equals 10. Then if I divide both sides by 5, we get x equals 2. Okay, so let's go ahead and write those as ordered pairs. Our y-intercept is the ordered pair 0, 10 thirds, and our x-intercept is the ordered pair 2, 0. So I'm just going to go ahead and box those. And the next part of our question says to change the equation into slope-intercept form. So we're going to start off with 5x plus 3y equals 10, and our goal is to get y by itself. So I'm going to go ahead and subtract 5x from both sides. And the left-hand side is now going to be 3y equals negative 5x plus 10. And then lastly, I just want to divide both sides by 3. So our final equation would be y equals negative 5 thirds x plus 10 thirds. And then that is our equation in slope-intercept form. So the other form that we're going to talk about today is called point-slope form. An equation of the form y minus y1 equals m times x minus x1, where y1 and x1 are real numbers, is said to be a linear equation in point-slope form. That is a mouthful. So let's see an example. Example 5 says, given the points 4, negative 3 and 3, negative 6, create a linear equation in slope-intercept form and point-slope form. The first thing that we want to do for either of these forms is we want to figure out the slope. And let us remind ourselves the slope formula is m equals y2 minus y1 over x2 minus x1. And that looks really daunting, but essentially we have our two ordered pairs and we just want to label them. So let's call that point x1 and y1. And then we can call these values x2 and y2. So now we can just plug those into our formula. So we get negative 6 minus 4 over 3 minus 4. Oops, sorry, that's a mistake. So it should be negative 6 minus negative 3 over 3 minus 4. Okay, that looks better. So that is the same thing as negative 6 plus 3 over 3 minus 4 is negative 1. and then that will be -3 over -1, which simplifies to 3. So what we've done so far is figured out our slope. And so now what we can do is, because we have two of our points that lie on our line, we can actually create our point slope form already. So we know that point slope form is y minus y1 is equal to m times x minus x1. And we have our slope, which is our m value, and then we could just plug in either of those points in for x1 and y1. So I'm just going to work with this first ordered pair, and I'll call this one again x1, and I'll call that y1. So then we have y minus -3 equals, our slope is 3, and then x minus 4. And then on the left-hand side, we can clean that up a little bit. That's the same thing as y plus 3 is equal to 3 times x minus 4. So this is our equation in point slope form. All right, and now if we take that equation and solve it for y, that's going to give us slope-intercept form. So let's go ahead and do that. So I have y plus 3 equals 3 times x minus 4. And if I distribute that 3 on the right-hand side of the equation, 3 times x is 3x, and then 3 times -4 is -12. And now I'm going to subtract 3 on both sides. And so we get y equals 3x minus 15. And that is our equation in slope-intercept form. Now, when I first learned about this, it kind of blew my mind, but you will get the same answer if you used this ordered pair as x1 and y1 when you're like plugging these into this equation. So I want you to pause this video and go ahead and plug that in and see that you're actually also going to get this equation here, and go ahead and verify that. All right, now let's talk about some line characteristics. We have some different variations of types of lines, and one of those types of lines is a horizontal line, which we saw in a previous example. Let me give you another example of a horizontal line, like for example, y equals 3. If I made an input-output table, what that means is no matter what input value I plug in, my output is always going to be 3. So if I plugged in 0, my output would be 3. If I plugged in 1, my output would be 3. If I plugged in 2, my output would be 3, and so on and so forth. So if you thought about the vending machine analogy, that just means that you have a vending machine where there's only one type of snack, like hot Cheetos, because hot Cheetos are amazing. So let's graph this and see what that looks like. Here's our y-axis, here's our x-axis. And so there's 3. And so if I plotted 0, 3, that would be right there. If I plotted 1, 3, that would be there, 2, 3. And if I connected those, notice that it makes a horizontal line. Okay, so an example of a vertical line is going to look like x equals -2. And what that means is, if I made an input-output table, no matter what my output is, my input is always going to be -2. So for example, -2, 0, -2, 1, -2, 2. So let's go ahead and plot those. So there's -2. So if I plot -2, 1, that would be right there. -2, 0 is right here. And -2, 2 is right there. Now notice that if I connected these 3 points, it forms a vertical line. Now, if you have been paying attention to the functions section, you might be asking yourself, wait, Mr. Kwan, this doesn't seem like it passes the vertical line test. And if you thought that to yourself, then you are absolutely right. This does not pass the vertical line test. So, vertical lines are not functions. Please don't ever go into a future math class and say that vertical lines are functions, because whoever your next math instructor is, they're going to be like, who taught you that? And then you're going to say, Mr. Kwan, and then your future math instructor is going to get mad at me. So don't do that. Vertical lines are not functions, okay? Now, the next type of characteristic we are going to talk about are perpendicular lines. And all those are is when you have two lines, when they intersect, they form a 90-degree or a right angle. So let me sketch a quick graph of what that's going to look like. So for example, if I had a line that looked like that, and then I had another line that looked like that, these are called perpendicular if when they intersect, they form a right or a 90-degree angle where they intersect. And if it was 90 degrees, then all four of these angles would be 90 degrees. And the important thing to know about perpendicular lines are that their slopes, the relationship between the two slopes is that their slopes are opposite reciprocals. What does that mean, Mr. Kwan? So, for example, let's say that we had y equals 2x plus 4. So we have an equation of a line here, and let's say someone asked you to come up with an equation of a line that is perpendicular to that line. The only requirement is that the slope needs to be the opposite reciprocal. And when we say opposite, we're talking about the sign. So since our slope in this example is 2, then whatever slope we have for our new equation has to be a negative number, because 2 is positive. So our new equation needs to be negative. So I threw in that negative sign there, and then it also has to be the reciprocal. And all the reciprocal means is that you flip the numerator and the denominator. Now you might be asking yourself, Mr. Kwan, 2 doesn't look like a fraction, but we can make it a fraction. So we have 2 over 1, because 2 divided by 1 is still 2. Now the reciprocal of this, the reciprocal is you just flipping the numerator and the denominator. So the reciprocal is going to be 1/2. So y equals negative 1/2 x. And then you can make your b value whatever you want. So negative 1/2 x minus 3, for example. Let's go ahead and graph these two on Desmos and just make sure that Mr. Kwan isn't lying to you and just spreading, false rumors. All right, so the first equation that we had was y equals 2x plus 4, I think was our equation. Let me go back and check. Yeah, y equals 2x plus 4. And then our other equation was y equals negative 1/2 x minus 3. So y equals negative 1/2 x minus 3. And look at that. When you look at the angles the way they're formed, they are in fact a right angle. So Mr. Kwan is not lying to you, at least about this.